Hey guys, how are you doing? Let me switch over to my other camera. Here we go. I got it. Hi guys, how you guys doing? You guys doing great? Hey, no problem, Dylan. I'm always happy to help, my friend. Glad you got a gifted sub. Gemma, how's your weekend? I hope you're doing good. Got a nice, beautiful day going on. Sorry about the banging in the background. They're working on some stuff here on some of the buildings. I'm a mental man. Thanks, Dylan. Appreciate that. You doing good, Gemma? Wonderful. Did you have a nice weekend? Yeah, I hope everything was pretty relaxed this weekend. Just finished college today? As in you finished school today or you finished college overall? Mental in a good way. Wonderful. That's what I like to hear. How you doing, Goldmesh? Doing good? Yeah, it was chill. Excellent, excellent. That's all I like to hear. If it was a nice, relaxing day of going to class and having a nice time, that's very good. Considering what you're doing, it is a super lot of fun. I'm sure. Get to get to go through your acting classes and whatnot. Hey, cool dad, how you doing this morning? Wonderful to see you, my friend. Good morning. Good morning. Zoom is still too high tech for you. Zoom isn't super high tech. You just have to click on the button. Although I don't like the camera necessarily pointing to you, if you're not into the camera stuff. I am because I'm streaming, but you know. Oh, okay. You don't finish college until next year, but your college day is over. That's good. That's good. Well, it's about Gemma. It's about yeah. It's actually right around 5 o'clock where you are at, so would make perfect sense if you're done for the day. Absolutely. I'm just starting my day. I'll be having a couple classes here, and then I'll be having another class at what would it be around midnight your time. So um, my schedule's a little bit all over the place every semester. So every year it's always different because I have different semesters. Jade, hello. Hey, how you doing, Jade? I hope you're doing really well here today, Jade. I hope you had a nice time yesterday. Um, watching the movie there. I don't know what movie you guys picked, but hopefully you guys had a nice time watching that movie. Um, you're very tired. Um, did you guys stay up pretty late watching the movie? Maybe that's why. I slept in a little bit myself today, so. That's how do you slowly turn off a camera? There's only a switch. Oh wow, you guys watch a lot of movies. Holy cow. Bug's Life. Oh my god. No. No, not a Bug's Life. Oh my gosh. This hey then bye. Wade, I've been doing really good, Wade. I've been really doing really well. It's already been a wonderful movie. The B movie. Uh, I don't even the A Bug's Life. I'm gonna be honest with you. Oh my gosh, a Bug's Life. You and Milky watch a TV show, then some YouTube. Awesome, very good. Me and A Bug's Life go way back. Cause when A Bug's Life came out on video, right? And I mean way back. I was working as a cashier at retail for an electronics store, and in the front there was a television right in front of the front counter, and it was playing A Bug's Life non-stop, non-stop, all day, every day. So by the time after a week passed, I memorized every single line in that movie. Like, no joke. I've memorized every single line in A Bug's Life. Absolutely crazy. Wall-E is a very good. Up is an amazing movie. Love Wall-E. I love Up. I have not seen Inside Out yet, and everybody says Inside Out is supposed to be absolutely amazing. So that's one of the movies I regret not seeing. I haven't seen Inside Out yet, so I think that's one of the movies I will probably go see on stream. Probably go get it and like watch it. Incredibles is very good. I like the Incredibles. Coco is very good. I cried too at Coco. I'd be honest with you, I cried to Coco. What a really good movie. Soul? I'm not sure what that means. Is that a movie? Soul? I don't think I've heard of that movie. I think Coco's a really super emotional movie at the end. It's so beautifully done. Absolutely beautifully done. Hey Megan, yeah, I guess we're talking about Pixar Disney movies. Yes. Oh, Soul is a movie on a Disney Plus. Oh, okay. If you like in the UK, then watch Friday Night Dinner. Okay, that sounds like a pretty good choice there. Definitely will. I think because I believe it's so connected to I believe it's so connected to family, Coco. You know, because it's so connected to family, it's just one of those things that we can relate to very much. Not only that, this Coco has a lot of great cultural significance too. Toy Story 2 is superior to other Toy Story films. That is facts. That is facts. Toy Story 1 comes close, but Toy Story 2 is by far superior. Agreed. Agreed! Toy Story 3 is the best for fighting. Come on, let's go! Listen, okay? I mean, stop. Alright, look. Let's just be honest here, okay? Spaceballs. Spaceballs. The best movie of all time. Spaceballs, alright? That's just how it is. Alright? Everybody's gotta understand. Spaceballs. The best movie ever. Oh my gosh. We don't have time for marbles today, Fainer, but I will play it on Wednesday if you'd like me to before class. Press F in the chat for Flacco taking that bottle to the head. What? What happened? What did I miss? Did Joe Flacco take a water bottle to the head? did I miss something, Wade? Lego Movie legit? Yeah, Lego Movie was legit. Loved that. Oh, Falco. Oh yeah. Okay, Falco. Wait. We talking sports here, Joe Flacco. Oh yeah, Falco. Yes. Okay, there we go. Chaz, hello. How you doing, my friend? I hope you're doing really well today. I hope you're doing excellent here today, my friend. Welcome to the stream. Welcome. Oh man, Monday morning. This is what makes my Mondays so amazing. Is all you guys make my Mondays so great. You know, Mondays are typically the roughest days of the week for most people, but I come in here and I get to talk with all of you who I've met little by little over time. And I mean, how can you go wrong with people like you? Could never go wrong. Mostly mad at Bonnie because Woody was the only toy that Andy wanted to keep. Bonnie's like, gimme just for her to never play with him. Yeah, that's true. Selfish kids. Did I watch the All-Star last night? No, I was actually watching AEW Revolution last night. So, I was watching AEW. I was watching wrestling last night. That's what I was doing. That was my whole night. Watching wrestling from like 6 o'clock to like 10:30 was wrestling. Poor Woody, glad he ran away. Yeah, right. Woody is always. Oh, Woody always gets himself in trouble. WandaVision was hype. Yeah, WandaVision was amazing. Oh, WandaVision was so good. You got a snake in your boot. Oh boy, be careful. um, yeah, no, seriously. Yeah, WandaVision was amazing. WandaVision was amazing. Love the end of WandaVision. Wonderful stuff. Lots of interesting tidbits for the Marvel Universe to go towards. Jade, have a fun time at work as best as you can. But enjoy yourself. Enjoy yourself for the rest of your day. If I don't see you, if I do see you on James' stream, I'm gonna say hello again. All right, Jade. Yeah, WandaVision got a lot better over time. It's like a very slow progression. It's a slow progression, Megan, but you'll start to see the mystery kind of add up and putting the pieces together. So it's something that you'll really, really like. KJ, thank you for the follow. Appreciate you. That's really super kind of you. Yeah, I highly suggest it because it ties in Megan. It ties a lot into the previous movies. All right, especially of course regarding Scarlet Witch and Vision, and of course Thanos and stuff. So I highly recommend it. At first, it doesn't seem like anything. It is weird, but once you start understanding why things are happening, the things about why they are, then you're like, oh yeah, this actually could be expanded upon into like a bigger universe sort of deal. It's actually really cool. Um, all right. Jerome, wow, Jerome with the subscription. What? Jerome with the sub. Wow. Thank you with the Prime sub. Thank you so much. Wow, that's really super kind. You didn't have to use a sub on me. Wow, man. Jerome Devs. Oh, jeez. Wow. Wow. Thank you so much, Jerome. That's super kind to use your Prime on a scrub like me. Um, I really appreciate it. Thank you so very much. You're very nice. Very kind. Um, all right. All right. You're working on your Oscar nominations prediction. You're putting money this year. You putting money on this year on Oscar nominations? Oh, don't bother. Oh no. Just go and just enjoy yourself, cool dad. Enjoy yourself, okay? Otherwise, you could just use the gambling things that I taught you. Okay, that's important. It's important. Ashley came to the early one today. Wonderful. I'm happy to see you in the early class today. Like Ashley, you could come to the early class at any moment in time. Okay. Actually, heck it. Money down, Nomad Land. Yeah, that got a lot of awards. Nomad Land. That's gonna help. Oh yeah. All right, ladies and gentlemen, we're gonna get going here. Let's get started. All right, we gotta do the intro. We're gonna get going here today. We're in for a nice little treat here. Let's do this. Okay, let's get started today. Welcome back. Welcome back not to Wednesday, to Monday. I can't even remember what day it is because it all flows together. But to Monday here. All right, hopefully a nice weekend. All right, so today we're gonna finish up chapter 6. Again, chapter 6 is only a couple sections here. But we're going to finish up chapter 6 here that deals with another type of distribution. All right. So we're going to be dealing with another type of distribution. Then we'll move on to chapter 7 that we've been talking about a lot about distributions like probability distributions in 6.1. Today we're going to be talking about what's called the binomial distribution here in section 6.2. And then on chapter 7, we're going to talk about things that we talked about before, which is the normal distribution. So we talked about that's what we'll do in chapter 7. But for now, we're going to focus on the end of chapter 6, which is section 6.2, which is talking about the binomial probability distribution. Now we can learn a few nice things here today. 1000%. Let's go to the big board here. Let's see what we're working with. All right. All right, so today is going to be a pretty important day using the calculator. So if you got the calculator, this is going to be one of those days where you're going to need to take it out, and we're going to be using it quite extensively. All right, and once again, just like we've talked about before, wording here is going to be incredibly important here because of the way how we have to set up things in the calculator to do these sort of problems. All right, so please listen carefully as we go through the process here about how we have to actually solve for some of these problems here using the binomial distribution. So that's kind of like the objective today. The objective today is determine whether something is binomial. Again, we're going to compute probabilities. So just type it out here. So we'll determine binomial. By the way, sorry if there's banging like hammers in the background and stuff like that. They're working on like a bunch of roofs in the background in my complex. So I do apologize if you hear like a bunch of noise in the background. Determine if binomial. Let's see, what else? Compute probabilities. Well, that'd be great. And determine mean and standard deviation of a binomial. All right. All right, so the question is, let's talk about this here. All right, let's talk about this here carefully, and we'll see exactly what we're working with here. So we want to determine if something's binomial. We want to compute the probabilities revolving a binomial random variable, and of course, determine the mean and standard deviation regarding a binomial random variable. Now, on paper, this looks very hard. In reality, it's not hard whatsoever. But what we do need to understand is what exactly is a binomial, what exactly qualifies as a binomial random variable, and exactly how does it work in the context of how we're going to solve for things. So the first thing that we have to understand is the word binomial. All right. In mathematics, let's just focus on the first part of that word. The first part of that word is bi. Now, bi means two, like binary. Binary means, like in computers, zeros and ones. Okay, so like every piece of data here is cut up into zeros and ones and then fed through a computer. And then, of course, you get stuff output on a machine. Fair enough. In this particular case, underneath a binomial distribution, we're only going to care about two things. All right, the only things we care about, I'm going to put this in the chat here. Things we care about are going to be only two things in a probability experiment. And that is success and failure. Okay, these are the two things that we're going to care about here in a binomial distribution. We only care about success and we only care about failure. That's it. Success and failure, it's as simple as that. Now, of course, let's take a look at the formula here, and let's break it down one piece at a time, as you can see here. And I kind of put it here as well. But let's take a look at the formula here, and we're going to look at this very carefully to see, break it down one piece at a time. Now, the formula here is the probability for x, and I guess I should place that x. Well, I should put it this way. Yes, yes. I'm going to switch this up here for just a second. All right. Let me put it as R here. I think that's a little more appropriate. All right. Okay, so the probability of R here in this case, and R is going to be the number of successes. All right, so the probability of R here is NCR. Okay, so we did talk about the number of combinations last time here. All right, times P to the R power times 1 minus P to the N minus R power. Now let's break this down one piece at a time here. First of all, N here is the number of trials. Okay, so how many times did we do this? Do this particular experiment. Okay, that's how many overall trials that we have here at the end of the day. R here is going to be the number of successes. So how many times did we succeed in this particular experiment? So for example here, we roll a 6-sided die, and then how many times did we roll a 4 and above? Okay, so whatever. P is the probability of that success. Of course, that can vary from scenario to scenario, so that's the probability of success. Now, on the other flip side here, we have 1 minus P. 1 minus P is the probability of failure. Again, that's using the rule of complements that we talked about before. Is that, okay, well, what's not? Not is always the rule of complements, which is 100% minus the probability. So 1 minus P would be failure, since we're only talking about things in contexts of success and failure. And finally, N minus R is the number of failures, because again, the number of trials minus the number of successes will leave you the number of failures, since we're only talking about two different things here in this particular section with the binomial distribution. Okay, so having said that, that's the formula here for the binomial distribution. Now, here's the issue that we have here. You could plug this into a calculator, 100%. This formula that you see on the screen, you can 100% plug this into a calculator. The problem with this is, as you can see in the formula is super long, okay? Lots of button presses to put combinations, and then you got to put the probability to this power and stuff like that. This gets even further complicated by the fact that you could have definitely more than one scenario. Like, for example, things that we've talked about before, like saying at least 5 being true, or at least 5 successes, or something to that effect. So we're going to have to look at different ways about how to approach different types of problems based on how it's written. The way I have set that up is what's next here, going to come up next here on the screen. Let's take a look. All right. As I mentioned here, wording is very important here. And let me show you why wording is very important. Now, this is going to come down to, specifically, this is going to come down to your calculator here. All right. So I want to point this out here. So I'm gonna separate this out here appropriately. All right. And the calculator here is what really is what we want to be focusing on here in this case. And I'll come back to you in a second. But I want to show this off on the screen. Okay, we're going to have two calculator functions, and I'll show you where to find these in just a second. But I would like you to write these down in your notes because they have two different meanings here. The first thing that we're going to have is what we call binomial PDF. Okay, we have binomial PDF here. So binomial PDF will be written with three things in mind. It will have the number of trials, the probability of success, and the number of successes. If you have an old school calculator, you'll need to write this down here for exactly this formatting, because you'll need to know what to enter in for every single number. If you have the new school calculator like I have off here to the left, well then you shouldn't have a problem whatsoever. Now, where do you find this exactly on the calculator? Let's at least talk about that here for just a moment. Find this on the calculator. Why don't you put this in chat here? So you hit the second and the vars key. So hit second and the vars key. So the vars key is right here, right where my mouse is hovering here. So second and the vars key will get you to this menu right here. And you can scroll up to letters A and B is what we're going to be wanting to focus on. So A here is binomial PDF. B here is binomial CD. Talk about it in just a second. All right. All right. So I'm going to go to letter A here for binomial PDF here. All right. And so there you can see exactly what I have written up here on the screen. Binomial PDF, first the number of trials, then the probability of success, that's what P represents, and then the number of successes here, that is the X value that you see here. If you have the old school calculator here, again, you won't see this on your screen, but you will need to know exactly what numbers you'll need to plug in depending on the scenario that you'll be given here in the given problem. Okay. Uh, before we move on here, before I start talking more about PDF here, are there any questions so far about that? I want to be crystal clear about this part here with the calculator because this basically is going to set up the rest of class here today. So I want to be sure that everybody can at least find this and find this consistently and understand it. Any questions so far? All right. Good stuff. Good stuff. All right. Now, what I want to talk about here, binomial PDF. Meow. What I want to talk about binomial PDF is that binomial PDF, specifically, what does binomial PDF mean? Binomial PDF means exactly that number of successes, and I underline here exactly. This is a very important. Wording here, as I mentioned here before, is incredibly important here. Binomial PDF as a function on your calculator is limited. So again, binomial PDF and CDF here are very limited functions, and you'll need to know those limitations. PDF here represents exactly those number of successes. Okay, so again, please be sure to write this down here. Definitely need to know again what the meaning of each one of these functions mean to use it in the correct context. Now, as you can see here for binomial CDF, the formatting for binomial CDF is the same as binomial PDF. No differences, exactly the same. We can find this, by the way, you can find binomial CDF, hit second in vars, and then you could go to letter B. Letter B here is binomial CDF, and you'll see, at least for the formatting, it's exactly the same. The number of trials, the probability of success, and the number of successes, respectively. All of that, no problem. The difference here, though, the big difference here in this case is that binomial CDF does not represent what binomial PDF does. Instead, binomial CDF represents less than or equal to that number of successes. Right? So be careful about this one. Less than or equal to that number of successes. All right? Less than or equal to that number of successes. So it is very limited in what you can do with binomial CDF because it only represents less than or equal to that number of successes. Keep that in mind, okay, as we go through some of these problems here. Okay, there is a severe limitation to what the calculator can do here. All right. Okay. So, having said that, let's go ahead and do a problem. All right. All right, so we need to do a problem here, and we need to talk about it. Okay. They hydrate today. Today is more milk tea here today, Athena. Actually, let me break this up again. Shake it up like a bartender. All right. Oh, warm milk tea? No, today a cold milk tea. Cold milk tea. Warm milk tea sounds great. Right now. But I usually drink cold drinks. In all honesty, it's typically what I do. This is matcha green tea plus milk. Go. I love me my matcha green tea. Gotta have some. Pretty important for me. Gotta wake myself up, you know. I got some milk coffee in the fridge, but and green tea is so good. Oh my gosh. Drink this stuff like forever. Oh boy. There we go. Alrighty. Bam. Alright, ladies and gentlemen. Let's do this. Okay. Alright, so we're going to go ahead and do number 37. Alright, so we're going to do number 37 here on in the book. Let me take out my paint tool here for you guys. This together. Alright. Okay, so let's read off number 37 and we'll see exactly what we're working with here. Okay. 37, toilet flushing. Okay. In the healthy hand washing survey conducted by the Bradley Corporation, it was found that 64% of adult Americans operate the flusher of toilets in public restrooms with their foot. Suppose a random sample of n equals 20 adult Americans is obtained and the number of X who flush public toilets with their foot is recorded. Okay. Now, I don't know if you flush toilets with your foot when you go to public restrooms. I have no idea. But I don't. I just wash my hands very vigorously though, because if there's anything on those toilets, that's true. So but I don't know if you guys do. It just depends. Yeah. You know, you want to know something, Ziggy? I asked this. I had this question here. A lot of people do. A lot of people flush public toilets with their foot because they feel it's gross. There's quite a few people who do. Fainer says you. Fainer says he does. All right, there you go. Aaron says she does. All right, there we go. Can't touch that dirty hand. That's fair, Wade. Yeah, you know, I was actually kind of surprised because most of the time I do the same thing you do, Ziggy. I'd be like, yeah, I just be like, oh, you know, I just kind of do it, and then I wash my hands with soap and everything. So, someone touches with their foot, why would you want to touch it with your hand? Well, I mean, I don't know. Everybody's got a thing. 195, 195 IQ. Aaron, by the way, did you get my math lab to work? By the way, Aaron, as my math lab is working for me. Did you get it to work on your browser there, Aaron? Want to be sure that everything's okay on your end. Let's see here. Okay. Just make sure to turn off your ad blockers and enable pop-ups and stuff. So just be sure you got that down on your browser. Um, okay. Yeah, so it looks like a lot of people do flush it with their foot, even in this class. Absolutely, 100%. So there you go. All right. So let's see here. Again, think of it this way. Why is this a binomial experiment? Because, as you can see here, some people, like myself and Ziggy, we will not use our foot. We'll use our hands, but some people here absolutely do flush with their foot. So again, it's either success, you flush with your foot, or failure, you don't flush with your foot. Fair enough. All right. Now let's look at letter B here. All right. So let's look at letter B. We're going to go through this together here. All right. Let's go through this carefully. Letter B says find and interpret the probability that exactly 12 flush public toilets with their foot. So again, probability of exactly 12. Okay. Can I zoom in? Yes. Just say. What do you want me to zoom in on? The book, Athena, or both? You can zoom in on this. I'll do both. Just to be on the safe side. Okay. Oh, the book? Sure. I can. Here we go. Sure that. Check to see if. Okay, I think that'll work. All right. Okay. So what am I going to use here? Nada. So what am I going to use here for the probability of exactly 12? What should I use here as my calculator function to find this particular probability? What should I use here? I should use PDF. Okay. Very good. All right. So you say you should use PDF here. Let's use binomial PDF. All right. So I agree with that so far. Binomial PDF is correct. Now, what numbers should I use here? What numbers should I use? So let's take a look at the breakdown here. I'm going to scroll over. Actually, yeah. Go back to your notes here for just a second. What number should I put here? So for binomial PDF, underneath our notes, we want the number of trials, probability of success, and the number of successes. Okay, so that's what we want here. All right. Let's go back to the book question here. What's the number of trials here? What are the number of trials here that I should put here first? Let's put a little poll here. We're not sure. I don't mind trying something. Oh, edge poll. There we go. Let's do a little poll there really quick. What do you guys think? Number of trials 20, 12, 64. Quick 1 minute poll. Okay. So, see everybody putting 20 down here? Very good. Very, very good. All right. I'm liking what I'm seeing. That's good. Okay. So 20, even before this vote is over, 20 is correct. Okay. So I agree with everybody here. 20 is absolutely 1000% correct. Okay. There are 20 people here that are being covered, right? Because that's our sample size here. Our sample size here happens to be 20 adult Americans. Okay. For this particular guy. Fair enough. Okay. Now, let's take a look here. We have the next number here is the probability for success. The probability for success. So, all right. So let's look it up here. What's the probability for success here? I think I should put here for that next one. Do another poll there. All right. Like we're doing good here. Okay. Like these polls, good. So I agree. Everybody who's voting in the poll there is correct. We're going to have 0.64. Okay. And then finally, not going to make a poll for this one here. What about the number of successes? What should I put there? Number of successes. What should I put there? You can put that in chat. 12. Okay, that's correct. Okay, so all right, 12 is correct. Spot on, everybody. No problem. All right, so we're going to plug this into the calculator. All right, so let's plug this into the calculator here. All right, so let's I guess this is wrong one here. So nicely done. 12 for sure. Okay. Oh wait, what? Here. I quit to the main screens. Okay. So we put 20, put 0.64, and put 12. Again, if you have the old school calculator, it's going to look exactly as you see here on the screen. You'll just have to enter in 20, comma, 0.64, comma, 12 yourself. Okay, so if you have the old school calculator, just follow exactly what you see here on the screen. Go ahead and put this in, and we'll get something back out. 0.1678 will be our answer for this. Okay. All right, spot on, Megan. That is correct. All righty. Let's look at the next one. All right, let's look at the next one here. This time, though, I'll read this one off here. We won't go back to the book here necessarily all the time. Find and interpret the probability that at least 16 flush with their foot. So the probability of when I presented this question a while ago, like when I first saw this a long time ago, yeah, I was kind of surprised myself, Ziggy. I ain't gonna lie. All right. The probability of at least 16. So the probability of at least 16. All right. Now let's at least talk about this here really quick. Which one are we going to do? Are we going to do PDF or CDF here? Are we doing PDF or CDF here? Okay. So that's correct. We're definitely doing CDF here. 100%. So I agree with everybody here. We're doing binomial CDF. All right. Now the real question is, what do we have to enter here for binomial CDF? Now, I'm going to go back to, I'm going to have the notes here on the right-hand side. I want you to read this carefully here for those notes on the right-hand side here. We have binomial CDF. I agree with that. I agree with you guys saying that's what we're going to use. I want at least 16. That's what I want for this problem, at least 16. So I want you to look carefully here. What numbers should I put underneath a binomial CDF here? (20.64) and 16. Okay. Now, I'm going to agree. I like both of those. I like those answers there from you, Kristen and Fainer. I like both of those answers very much, but I'm going to agree with 2 out of 3 of them. I'm going to like 20 and 0.64. Those parts are pretty easy. So those parts, no problem. 16 part, maybe not so much. Not so much. What could that last number be? I'm not sure why we're using 12 again. 15. Okay. Now, if I said, I agree with you, Ziggy, if I said, hey, it is 15, take a look at that here. I'm gonna agree with you here, Ziggy. I like 15, but you're probably not sure why you probably agree. I probably agree with that guess of 15. Let's talk about this here for just a moment. Okay, we're gonna actually be 4. Now, wouldn't it be more than 16 since it's at least 16? All of these are very good reasons. I like these reasonings that you guys are coming up with because this is going to highlight the crux of this section, is that the wording and the limitations that were given here, okay, if we're looking at the wording and the limitations that were given here, we have to be extra careful about what we enter here. Now, I agree with Ziggy's guess of 15, but maybe he's not sure why that actually happens to be the case. So let's take a look at why 15 is actually the correct answer, but is only part of the correct answer. I actually left out something else, by the way. I will point that out in just a moment. All right. In reality, what you want is you have 2 scenarios here, okay? Remember how binomial CDF works. Binomial CDF works in terms of less than or equal to. You are only limited to less than or equal to. You cannot have anything else other than less than or equal to underneath a binomial CDF scenario. So what you have is you want at least 16. So what you want is you want 16, 17, 18, 19, and 20. That's what you want, okay? You want 16, 17, 18, 19, and 20. But you have a function that only serves less than or equal to. So you need to be very creative in order to make it work out. So what you have is you have 2 halves. You have the scenarios of cases between 0 and 15, and 16 to 20. Now, if you just draw a little picture out here, you want to get rid of everything that is from 0 to 15 and leave 16 to 20. Okay? That's what you want at the end of the day. Okay? You want to remove all the cases between 0 to 15, and then you'll be remaining the 16 to 20 cases, and then whatever that adds up to, that will be what you have at the end of the day. But in order to have that happen, we need to use, once again, our good friend that we have used before. All right. And what is that good friend we have used before? Well, that good friend we have used before is the rule of complements. we need to put 1 minus binomial CDF in that regard. Okay, so we're going to use the rule of complements here. All right, for at least. Okay, so for more than. Okay, letters in math and no thanks. I believe that's how theories are done, Rob. I believe that's how theories are done. Got to do letters in math. Got to do it. So you have to use the rule of complements for at least or more than, all right? Because you are limited into what binomial CDF is. Binomial CDF is a limited function in the calculator. It's a limited function, so you have to work around that limitation in the function itself. All right, you don't have a choice in the matter. It's a limited function, so that's why I put 1 minus binomial CDF 20, comma 0.64, comma 15. That'll remove a 0 to 15, and there you go. Yeah, I always wash my hands. I make sure I use soap and water, wash my hands. So 1.011, I think that's right. Let's go ahead and check it out. All right, so here, let's go ahead and do it. We go 1 minus, and then we'll hit second in vars. Go to binomial CDF here. 20.64 and 15. And that's correct. I agree with you there, Cool Dad. Absolutely 100%. So 1011, absolutely spot on. All right. Any questions about that so far? Any questions so far? Want to be sure everybody understands where we're going with this. Got a few more examples to do. So again, wording here is going to be one of those tricky things, but this is definitely where it's going to be, definitely where you're going to see this. So that's fine. That's fine. That's why we have replays, Megan. Go through this carefully. Do we always have to do 1 minus for binomial CDF? No. Remember, this is applicable here, Tristan. So the answer to that is no. And the reason why it's no here is because this references at least 16. If you see at least 16 or more than 16 or whatever, then you do 1 minus. However, to additionally add on to this question here, let me show you another example here, Tristan, where that is not the case, okay? Let me show you where that is not the case. So let me do another example here. This was my next example anyway, so no worries. But this one's my own example, not in the book. But we'll just label this as letter D. What's the probability of less than 14? So what is the probability of less than 14? So, okay. Can you tell me how would you set this up here? The probability of less than 14. All right, so I'm going to keep this up here on the screen. So the probability of less than 14, how would we set that up to figure out on the calculator? How would we set that up there? Less than 14. Okay, so I agree. FIFA King, I don't even know what -2 means. If -2 represents the chances of winning at FIFA, man, that's a pretty poor percentage right there. The -200%. That'd be pretty bad. Now I agree with 0.64 here. 14. What number should I put as that last one there? I need to put 13. 13, that's correct. I need to put 13 here. Right. Let's talk about that here for just a second. Remember, this says less than 14. Note the difference here. This says less than 14. So when you save less than 14, you want 0 to 13 here. You don't want 0 to 14. Right. 14 does not count. Right. 14 does not count. If I said 14 or less, if I just as an aside here, if I said 14 or less, okay, this includes 14. All right. Right? So if I said 14 or less, this includes 14. That part is definitely true. Right? All right, so there's this subtle difference between both of those types of wordings here. Less than 14 means you do not. Less than 14 here means we do not include 14. But 14 or less means we do include 14. Okay? So let's do this on the calculator here. Let's see what we get here. All right? We're going to do second in vars here once again. And so we're going to hit 20 and then 0.64, and we'll go ahead and hit 13 here for less than 14. And so we get 0.6197. Can we do this on Zoom? No. No thanks. Okay. All right. Let's do another couple of examples here. Okay. So I want to see how you guys do when you're looking at this wording very carefully. All right. So I'm going to do another one here. I'm going to go a little bit out of order, but nevertheless important nonetheless. So let's do the next one. All right. Do this next one here. The probability of more than 16. The probability of more than 16. So the probability of more than 16. So how will we set up this problem here? I'll give you guys a minute or so. You guys can set this up right. Probability of more than 16. Okay, you're really all right. So everything you wrote there, Tristan, I agree with, but you're missing something. Other way around, guys. You can't have a negative probability. Use the rule of use the law of complements properly here, please. Not 1 plus, otherwise you'll have something above 1. 1 minus. Okay, good. Remember, it's not -1. It's 1 minus. 100%. minus that probability. Okay, so 100% minus that probability. That's right. So 1 minus, okay, again, using the law of complements here, I'm going to use 1 minus 100% minus that binomial CDF. That's okay. 20, comma 0.64. And then Tristan, you had 17, and 17 is correct. So Cool Dad here, you put 16 here. Notice it says more than 16, so you want scenarios 17 to 20. So if you want, again, your goal here is to get rid of the first, oh, actually, wait. You want to get rid of the first 16 scenarios. Oh, you're correct, actually. I take that back. Let me get rid of this. I need 16. Yeah, got to be careful about that. All right, so we want 17 to 20, but we want to get rid of the first 16 scenarios, okay? So, yeah, Tristan, you have to be a little careful about that. You're correct about 17, 18, 19, 20. Okay, you're correct about that. But since we can only work within the context of less than or equal to, want to get rid of the first 16 possibilities, leaving us with 17, 18, 19, and 20 left over. Okay, so that's why we're going to put 16. That will ensure 17, 18, 19, and 20 are the only probabilities that are left over, and that will represent everything else. Are there any questions about that? The wording, I know. But that's why we're going over these problems very, very carefully and very, very slowly. Okay, the wording there, it can be killer. I'm not gonna lie. But that's what I warned you about back in chapter 5. Back in chapter 5, that was the first instance of where I told you wording was going to matter. And you can see how wording is going to matter quite significantly here, starting from then. No, 16 was correct, and that was my fault. Um, so if it was more than 17, it would be 17 then? That's correct, Athena. That would be correct. If it was more than 17, correct. Because 17 is not included. It would be 18, 19, and 20. That's correct. Yeah, that wording is very, very tricky and it can trip up a lot of people. Again, we're just going over this slowly and carefully so that way everybody can see exactly where we are down the line for each one of these scenarios. We haven't gotten to the last scenario yet. We have one more scenario, by the way, so we're not quite out of the woods just yet. But let's take a look here at the probability for this. So 1 minus binomial CDF, I'm going to put 20.64, 16 here. All right. And we're going to get 0.0366. All right, so 0.6. Okay. Okay. Now, I'm going to have one more scenario for you here to kind of look at. Okay. So this scenario here is going to be a bit tricky, but let's go ahead and go through with this here. And again, we're going to see exactly how we can attack this type of problem here. All right. This one here, let's I'll give you guys a minute or so to try this one out and then see if you guys can get this one. This will be letter F. I'll pay respects to your brain cells. I'll just write F. All right, so I'm going to modify this one here. So the probability between 8 and 12. So the probability between 8 and 12. Now my suggestion to you is for this one here, if you're going to think this one through, think of it drawing out a picture here about drawing out your scenarios here, okay? Probability between 8 and 12. Probability between 8 and 12. And you may, another hint here, you may need 2 binomial guys for this one. All right, so let me go. You guys think you got something there, or don't worry about it. See if you guys get it here. Oh, probability between 8 and 12. Cool, Dad has an answer there with a couple binomial CDFs. Okay. All right. That is correct. That is correct, Cool Dad. That is absolutely correct. It does include 8 and it does include 12. Okay. All right. Let's hopefully you guys have got something down here. Cool Dad put down an answer here. It says binomial CDF 20, 0.64. So go back to your notes there, Megan. Let's go back once again. There's the difference right there. So it says right here in the notes. PDF means exactly that number of successes. And CDF here means less than or equal to. So Megan, I would highly suggest to write this down in the notes, because you're going to need that here in order to get this down. So this is definitely one of those things you definitely need to write down to know what each function in the calculator does. Otherwise, it's going to be very, very difficult to work with. This I can guarantee. You're locking it in. Locking it in, bro. Yeah. All right. Well, let's take a gander here, shall we? Okay. So the probability between 8 and 12. Okay. So what we want to do here is, if you're going to visualize this here, we want everything between 8 and 12. Now remember how it works. How it works is that we could kind of do it like we did the rule of complements, only we're not taking the entire 100% here. We're first taking all the scenarios between 0 and 12. What we want to do is we want everything between 8 and 12. This is what we want, okay? So let's not forget. We want everything between 8 to 12. So we're including number 8 here. So if we start off with everything between 0 and 12, and we want everything between 8 and 12, we want to remove, what we want to remove is all the scenarios from 0 to 7. So 0 to 7 has to go away. That has to be eliminated altogether. So the first thing that we're going to do here is we're going to take binomial CDF. We'll take all the scenarios up to 12. We'll do 20.64 and 12. And then we're going to remove all the scenarios from 0 to 7. So, Cool Dad, you had it exactly correct. Expand that. All right, so we have binomial CDF 20, comma 0.64, comma 12, minus binomial CDF 20, comma 0.64, comma 7. And we want to go ahead and put that into the calculator. And we're going to do this binomial CDF twice, okay, as you can see here on the screen. And we'll see what we get. Let's do it. So second in vars, let's go to binomial CDF. All right, so 20, comma 0.64, comma 12. Oh, well, be helpful if I actually put it in. I'm so used to doing it via the old school method, an old school calculator. And then we're going to subtract that by second vars. And then we'll go 20.64 and 7. Too bad R. Kelly the guy ain't so great. I'm just gonna be honest with you. All right, so we do get our final answer here. Oh, got a hydrate here by Ashley. Give me just a second here. So we got 0.4282 is correct. Yes, 0.4282 is correct. Yeah. Very nicely done. Very nicely done. All right. Very good. Are there any questions about that? Yes, perfect. That's correct. Are there any questions about that? Does everybody understand where we got these numbers from? Again, please feel free to ask me questions about this because there's I know that we went over this slow, yes, but want to be sure that you understand the wording behind the wording and the reasoning behind why we set up the calculations in that specific way. Any questions, guys? Please ask. All the secondaries. Oh gosh. I don't even know how many channel points everybody has. I gotta think of something. I gotta think of something to do with channel points. So any questions, guys? Any questions? Say something nice. Ashley, you're a wonderful person and you should continue being you. Just be yourself and be wonderful. Ever watched Trapped in the Closet? No, I haven't. No questions? Okay. Go ahead, Ashley. You could ask me a question. It's fine. As it does not all the buttons. Thoughts on the vaccine? Glad you asked that question there. Yeah, actually, let me show this. Show this here. I over the weekend. I got got my first shot. Hey. So yeah, I got my first shot of the vaccine over the weekend. So I will get Trapped in the Closet is really bad. Like a really bad movie, like bad as in funny bad or just bad bad. There's many types of bad movies out there. Like yeah, very bad, but it's like okay, guys, understand. Oh, bad, okay, good. I have to know because funny bad, it's like it's so bad it's funny, but it's like if it's like bad, then it's like this is a slug to just watch and I just don't want to watch it. So, yeah, I got the vaccine over the weekend there. Uh Basically they vaccine takes all of like 3 seconds to do and they have you sit in a chair for maybe 15 minutes and that was pretty much it. You having a hard time finding a place to get shot? Well, I didn't get my shot in Illinois, so went up to Milwaukee. Somebody recommended that I go to Milwaukee to go get a shot, so I called up there. I called up to Milwaukee and they said, "Hey, um, wanna come take the shot?" And it said, "Yeah." Like, okay, we'll schedule it for noon, and there you go. I was able to get it, no problem. So up and with You're in healthcare, but all the appointments are booked. Oh no. Think you have to tell your boss before I get it, even if you do? Why? Why do you have to tell your boss? Yeah, so I went I went up to Milwaukee. Yeah, if there's places in Wisconsin that are giving away the vaccines at a much faster clip than what we're doing down here because we apparently have no idea what we're doing. So I don't know. I know some people like you guys are if you guys are in the healthcare field and you guys want to get access to the vaccine, but it's really slow for you. Think about if you can cross state lines there. I actually asked. So because I was feeling. I'll be honest with you. I was feeling a little guilty because I'm like, I don't want to cross state lines and take away a vaccine from someone else, right? So I called ahead and said, "Hey, is it okay if I, cross state lines and get a vaccine?" She's like, "Oh, there's a lot of people who've been doing that." So I'm like, "Okay, I don't feel so bad about, going cross state lines if I'm given permission to go ahead and get the vaccine from them." So I did, and then I'll be going next month to get my second dose. So um so there are places like I went to this place I went to the Muslim Community Health Center. Um, that's where this one was. There's a lot of different people who were there anyway. So they're like a kind of a free clinic there. I can give you a number here. Hang on a second. Uh, just a second here, folks. All right, so let's see. I need to put that down too. Remember to, of course, call ahead first to schedule an appointment. But they'll need your ID and an insurance card. Um, so this is where I got my my first shot from, or my shot. Well, I get both of my shots here. So, any life wisdom I would like to bestow upon you? Well, you guys saw the meaning of life. That's one of my commands. I think that's one of my commands. Yes. Yeah. You know, I tried not to be, just you're opting not to receive the vaccine. That's fair, Feiner. I respect that decision very much. I think that once it get closer to like summertime, Feiner, I think then maybe if you wanted to, you can go get the vaccine because it'll be pretty readily available probably by that point in time when it gets into be in distribution. So to be fair, it's going to be there's going to be many more vaccines available in terms of for the population, but people who do work in the healthcare field should get it right away so they don't endanger themselves or the people that they are working with. So I'm surprised that they haven't gotten there. So I put it there. There's the again the phone number. Please go ahead and call ahead if you'd like to call ahead and schedule an appointment about when you can get your vaccine done. So the ones at MCHC, by the way, they're doing the Moderna vaccine. Uh, so the Moderna vaccine there. Uh, if that's what you want to know, what vaccine do they actually put in? Is the Moderna one. So the only thing that I had, just to let you know, because I want full disclosure here. So I don't like lying about things about that. So I believe I sat in the room for like 15 minutes, and I got a little dizzy. I sat in my car for like another 15 minutes, and then I was like, okay, it kind of went away, and it was okay the rest of the day. The only other thing that I had was like I had a sore arm here. I still have a bit of a sore arm here, but other than that, there was no other reactions that I really felt. So I just want to be a full disclosure there about how I felt when I got my first vaccine. I will let you know, of course, in due time in April. Beginning of April is when I get my second vaccine. So I just want to let you know that I'll let you know of any other effects that I feel. So um, it was a very light dizziness, by the way. It wasn't like super dizzy. So just to let you know, very, very light dizziness for maybe a short, brief period of time. And then I just laid back, relaxed a bit, had a few snacks that they had there. They have some drinks and snacks and stuff. So what homework should we do? Um, what homework should we do for next Wednesday? For next Wednesday. You mean this Wednesday? You should have everything up to chapter 6, so section 6.2. So so up to section 6.2. All right. Yeah, of course, every person's going to react differently with the vaccine. Okay. Every person's going to react differently with the vaccine. Understand that. Okay. So for me, I had some very light dizziness, but not everybody has not everybody's going to react the same way. Different body constitutions and whatnot. Listen, Ashley, Athena, listen to me very carefully. Regardless of that, I hope that I've given you an alternative about where you can find a vaccine so you can feel safe about the things that you're doing. All right. So if you guys feel safer, getting that first dose of the vaccine there, because you're working in the healthcare field, go ahead and get the vaccine there. Go to Wisconsin if you can. Right? Call it. You have to call and schedule an appointment. But once you do, go ahead and schedule an appointment and get that vaccine right away. Okay, you shouldn't have to, Athena. You shouldn't have to suffer through something like that. Okay, I'm not even joking about this. If you feel disrespected in your field, if you feel like it doesn't matter. This is a choice. This is a choice. It's like what Feiner said. That's a choice that Feiner made for. Feiner made is like, I'm not going to go get the vaccine. I totally understand that. If you feel you want to go get the vaccine, then go get the go get the vaccine. You found one in DeKalb, wonderful. Okay, you have to call at 6 a.m. tomorrow. Wow, that's early. But yeah, again, I want to give you as many alternatives as you guys can if you feel that you would like to go get the vaccine. It doesn't mean you'd have to, but if you feel that it's important and necessary for you, then I feel it is because I want to be sure that everybody around me doesn't get I want to be sure that if I walk around in public and stuff like that, I want to be sure that I'm doing my part, but and stuff like that. So makes perfect sense to me. Just say Athena. Just say you're like a nurse or something. Because pretty much you are. It's just a title, but you're still doing the same things as a regular nurse. So it's hard. It's hard to find the vaccine in Illinois at the moment. I don't know why, but yeah, like I said, I respect everybody's opinion when it comes to the vaccine and things like that. Ooh, Decatur. Ooh, ooh. Yeah, Decatur's a little far. I used to live in Decatur when I was a kid. That's pretty far. That's about 4 or 5 hours away. All right. Wait, nice week. You mean you're not coming back on Wednesday, Megan? I hope you're coming back on Wednesday, Megan. Please say you're coming. Decatur is farther than Milwaukee. It takes. Oh, you are okay. Good. Good. I'm happy you're coming back Wednesday. I was worried about that. Yeah, I live in Schaumburg, guys, and to drive up to that place in Milwaukee, it took me about 60 miles, 60 70 miles. So it took me about an hour and a half. Just going from 90 to like 294 and then driving straight north. It's right along 294 and not too far off the highway. You guys can find it pretty easily. Just use your nav. Use your GPS. Hmm. We all wish we were Titans, Wade. We all wish we were Titans. You take it? Everybody wants the spinal fluid. Everyone wants it. People are like, oops, that was meant for Aaron. I'm so sorry. Yeah, don't forget about those side effects there, okay? Don't forget the side effects of brooding, dark corners, and irrational anger. All right? That's always true when you take the spinal fluid, all right? Always. Oh my goodness. You guys are nuts. feel bad for the people around me, then I'll be fine. All right. Definitely glad you picked the first class. Wonderful. Like I said, Ashley, you're welcome in either class. I don't mind either way. All right, everybody. We are done here for the day. I want to thank everybody very much for coming on out here to the stream once again. My next class is here is in 10 minutes. Yes, indeed. We got a next class here in 10 minutes. Anna, I hope you're doing well, by the way. You love our class is very unpredictable besides math. It's pretty much how it's supposed to go, Athena. There's not supposed to be predictability about what happens on this stream. You're great? Wonderful, Anna. I'm so happy to hear that. Did you have a good weekend? I hope you did. You guys take this in directions I'll never understand, but I love it. All right. Yeah, try and get appointments for vaccines. If not, that's fine. I will see you all on Wednesday. All right. Oh, good. I'm happy to hear that. For those of you who came for the first class there, I will see you back on Wednesday, okay? If you'd like to come to office hours here, it'll be at 2 o'clock, okay? Please email me if you would like me to come back on. All right? I have more figures, Ashley. I just haven't taken them out of the box yet, so... yeah, there's more figures I got. Alright, have a great day, guys who came to the first class here. We will see you on Wednesday. For those of you here for the second class here for 12:30, I'm going to stay right here for you for the next 10 minutes or so, and we'll get right into that second class, I promise you. Okay? You think of any help with office hours? Okay. Yeah, just let me know through Discord there, Athena. Or you can email me or whatever you like, okay? And then I can certainly will be able to help you. Not a problem, okay? Cool beans. All right. Discord is probably a bit easier because it's easier to access, but whatever you like. All right. Have yourself a great day. Yes. Look at all this. Look at the positive vibes here today, ladies and gentlemen. Positive vibes. Vibes, indeed. More vibes. Yeah, now Ziggy, have a great one, my friend. We will see you on Wednesday. We'll see you on Wednesday, my friend. Of course. Of course we'll see you on Wednesday. Have another rip-roaring day. Back in Chapter 7, that is. Ooh. Oh, I had to do that part. Well, I'll do that on Wednesday. That's okay. I do not mind. Man, the positive vibes are real today. Super real. This. Absolutely banana-ramas. Let's see here. Oh, yeah. Probably should just wait. Okay. Cool. Hopefully we'll have a few more people here joining us for the second class of Math 102. Okay, let's see here. Hmm. All right, we got about 5 minutes there. Alrighty. Alrighty. Oh. Hello, 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 everybody who's decided to stick around here. Oh, Hazelnut's in the chat. How you doing? I hope you're doing well. Yes. Hey, Cheska, happy Monday. We're able to make the first class. That's okay. You're here for the second class, and that's all good. Your dad's home, so all is well. Wonderful. Was your dad away for a while? Was he like on a business trip or something? Or was your dad I don't know if your dad's Oh. Well, I'm very sorry to hear that he was hit with the Rona. But he hospitalized and he busted through like a champ. What a man. What a man. Your dad is a true gentleman. And he kicked COVID's ass. I'm very happy to hear that. I'm very happy to hear that. Very, very happy to hear that. I'm so happy to hear that. Absolutely 100%. Respect. Respect, Hazelnut. Respect. Ass kicking COVID, there's nothing wrong with that. And probably the rare time there, but yeah, it definitely deserves those accolades. I'm glad he's feeling a lot better. And I'm glad you and your family are doing well. Look at that. I'm so happy. Look at that. Positive vibes already this weekend. Man, dad's back. And we got some good math going on here today. Well, at least I hope it's good math. We're gonna try our best though. All right, we're about a couple minutes away from getting going here, so we'll wait just a little bit and then we'll move. We'll move on and do a little bit of stuff here. All right. All right. All right. So it is 12:30. All righty. All right. We will get going here. Okie dokie. Let's go ahead and get going here. And we'll do some intro stuff here, ladies and gentlemen, today. And we will get going. All right. Hopefully, buddy. Ooh, excuse me. Ooh. All right. Hopefully, everybody is ready, rip roaring to go, because I am for sure. All right. Let's go going here. Let's get started here. Let's do the intro. Well, that's really good to hear, JD. Thank goodness. I'm happy to hear that you do not have COVID. I don't wish the Rona on anyone. It is definitely not fun. Definitely not fun to feel very, very miserable. But you are feeling better. That's good. Very happy to hear that. Very, very happy to hear that. Thank goodness. Thank goodness that you are feeling better. All right. Let's do this. Let's do this intro here. Okay, let's get started today. Welcome back to Wednesday. No, not Wednesday, folks. I still have this wrong. It's not Wednesday, although I just looked at Wednesday. Welcome back to Monday. Oh, very nice weekend. All right, so today we're going to continue on here with section 6.2. All right, so section 6.2 here. We're going to continue on talking about distributions. Today we're going to look at a binomial distribution, so another type of distribution here. Previously we looked at a probability distribution. All right, so we're going to be focusing on, again, chapter 6 is just 2 sections here, so it's just this section here. We're going to finish off chapter 6 here today, and then with section 6.2, and then we'll move on to chapter 7. Chapter 7 here will deal with normal distributions, which we'll do on Wednesday. So today is binomial distribution here today. So let's go to the big board here. Let's see what we're talking about here. And by the way, if you have your calculator with you here today, you may want to take that out here because we're going to use that here pretty extensively for this particular section. Okay, so today is going to be pretty calculator heavy. All right, so let's go ahead and go to the big board here and see what we're working with. Again, I do apologize for the banging in the background. They're working on like the roofing and stuff for other buildings in and around the complex. So if you do hear some hammering and banging, that's what we're doing. All right. In any case, let's talk about what we're discussing here today. Today, talking about determining if something is binomial. We'll be computing probabilities around the binomial random variable, binomial distribution, and determine the mean and standard deviation of binomial random variable. We'll actually do that on Wednesday because I didn't last class, so I want to keep the same pace. So probably just end up doing the first 2 things, and then the last thing will take us maybe about 5 minutes on Wednesday. We'll quickly do that. All right. In any case, though, the most important part here is going to be the first 2 parts here. So let's talk about that here right away. All right. So let's look at question 1 here. The only question here that really we're going to focus on here today is what is the formula for the binomial distribution? Now, let's talk about the idea about what binomial means in mathematics. Now, binomial means, let's focus on the word bi. Okay, now bi here as a prefix means, bi means like two, okay? It means two. So for example, um, binary, we talk about in a computer, talks about ones and zeros, okay? So if you want to process data, it's all processed in terms of ones and zeros. And then, of course, it's fed to a computer and outputs something else. Fair enough. All right. What we want to look at here is we're going to want to have two scenarios here underneath the binomial distribution. And so the only two things that we have to remember here, and the only two things that we want to remember here, is we only want to remember success and failure. So the only two things that we care about here in this section is going to revolve around the words success and failure, because what we're going to be doing is we're going to be doing a probability experiment where either we succeed in that scenario or we fail in that scenario. Okay, so we only have two choices. So just like binary is ones and zeros, we have success and failure here as well as our two respective choices here underneath a probability scenario. So how does the formula work? Let's take a look at the formula here. Let's break it down. So here we have the probability of R. R here will be, again, we'll talk about here R here, but it'll be the number of combinations of R, okay, times P to the R times 1 minus P to the N minus R. Now let's break it down here for just a second. Okay, now obviously there's a lot of floating parts, so let's go slow over the formula here so we at least understand where each part would go. And here's the number of trials, okay? So how many times do we try this, try this scenario here? Whether it be rolling dice or whether it be, you know, um, seeing how many people do a certain thing. All right, that would be how many people do we ask, okay? All right, or how many people, how many times do we do that certain something? That would be the number of trials. R here, the most important part, is the number of successes. How many times do we succeed under that scenario? So, for example, we roll a six-sided die. How many times we could count as a success as rolling a four or more? Okay, so that would be counted as a success, for example, underneath that particular scenario. P is the probability of that success. Okay, so that could take on any amount here between 0 and 1. Finally, when we look at the other side of things, if we take 1 minus p, so if you remember the rule of complements there, the rule of complements says, well, that's the word not, so not success would be failure. So that would be 1 minus p. So 1 minus the probability of success would be the probability of failure. And n minus r here, take away the number of successes from the total number of trials, and those are going to be your number of failures. So this is how we would write this formula out here appropriately here for the binomial distribution. Now, one of the things here that is very important to know is that if you look at this formula here is, it's pretty long, okay? And this particular formula here covers maybe one scenario out of the many possible scenarios that you can have within the study. So, for example, you could have scenarios where you're adding up a couple of things there together. Lacey, thank you for the follow. Appreciate you. So we could have many different types of scenarios there, in that regard. So you could have, like, say, five rolls of four or more, six rolls of four or more, seven rolls, and you'd have to do this like 3 times. And you can see how long that could be when you're just trying to plug it in a calculator. That gets to be really, really cumbersome, very, very bothering, very, very quickly. So we need faster ways of which to do this, and that's where the calculator is going to come into play. Now, one of the things that we've talked about here back in chapter 5 is going to rear its ugly head here in this particular section, and that is regarding the wording here in some of these problems. The wording here is going to be incredibly important because this is going to directly affect the calculations and the way we have to do those particular calculations in the given problem. So please follow along carefully here so you understand exactly how we are going to enter stuff in and how things are going to work. Okay, wording here is incredibly important. Incredibly important. That's why I put the second key wording here. Wording is important. This is so true in this particular case here. You're a 9th grader and doing okay in math right now. Ooh, that's good. Very, very nice. What math are you doing right now, Lacey, if I may ask? While you're going to answer that question there, I'm going to go to the calculator portion here. Let me go to calculator. Okay. Let's talk about the calculator here. So we're going to have 2 calculator scenarios, okay? We're going to have 2 calculator scenarios. So we're going to have 2 functions here on the calculator that we want to look at. So let's calculator. Yep. Okay, so on the calculator here, specifically on the calculator, we're going to look at 2 specific scenarios, i.e. 2 specific functions on said calculator. The first thing I'm going to do is we're going to look at binomial. We're going to learn how to factor binomials and trinomials. Ooh, there you go. You're going to need to memorize some of them rules, right? Don't forget about that. A squared minus b squared, a plus b times a minus b. Binomial is a squared minus 2ab plus c plus b squared. There you go. Things like that. You? What's wrong with factoring binomials, trinomials? The X method's your favorite. Very nice. Very nice. I see no issues with this. Hurts your brain? Oh no. Well, if it makes you feel any better, I'm about to hurt your brain even more. Green tea, outstanding. All right. Okay. I'm sorry. Well, Lacey got a point, factoring binomials and trinomials may be sometimes a bit easier than what I'm probably going to present here, so. Let's go over these calculator functions here. So here we have binomial PDF. Hey, Jose. How you doing, my friend? So here we have binomial PDF. Now, binomial PDF here, where can you find these functions on the calculator? Let me be specific about this here for just a moment. If you hit the second key on your calculator, so let me put this in the chat here, okay? So go ahead and hit the second key, and then hit the vars key, okay? And we're going to go to letter A. This is going well, Jose, my friend. Going very well. All right, so we're going to hit the second key and the vars key. So the second key here and the vars key is right here, right where my mouse is hovering. We'll go ahead and hit that. And we're going to scroll up to here. If you see letters A and B here, binomial PDF is letter A, and B here is binomial CDF. So we're going to be using one of these 2 functions here given the scenario. Okay, so let's take a look at binomial PDF here first. Okay. So binomial PDF here, let's break this down. Now, if you have the old school calculator, exactly what do you need to put underneath the old school calculator? This would be the number of trials, okay, meaning say how many times did you try that particular experiment. The probability of success, that's what P here represents here in the calculator. And the X value here is the number of successes. Okay, so the number of successes here in this particular scenario. Okay, now, more importantly than that, besides the numbers that you would put into this function on the calculator, more importantly in that is what binomial PDF represents. What binomial PDF represents specifically is this specifically talks about exactly that number of successes. This is really important for you to know. I would highly recommend you write this down because, again, you need to know that the calculator here, despite it being a big, robust machine, does have limitations, and we have to work with these limitations here depending on the situation that we're encountering. So, this is like, again, binomial PDF only works with exactly that number of successes. That's it. Okay. So we'll do some examples here shortly in just a second, but I want you to understand that this is going to be a pretty big deal here for the examples that we're going to show off here today. Okay. Now, how about the other side of things? Well, let's take a look at binomial CDF. Now, binomial CDF is exactly the same as binomial PDF in terms of what numbers you need to put in. So if I go to second in vars, I go to binomial CDF, the numbers that we put in are exactly the same. So the number of trials, the probability of success, and the number of successes at the end of the day, all that is well and good. All right, just exactly like binomial PDF. However, the most important part here regarding binomial CDF is that binomial CDF is a very limited function here on the calculator. What is that limited function? That limitation that binomial CDF is that binomial CDF represents less than or equal to that number of successes. Okay, so understand that you are limited. The limitation here on the calculator for binomial CDF is less than or equal to that number of successes. And this will play an important role here in several of the examples we're going to look at here today into how we're actually going to solve for some of these particular examples. Let's look at some of these examples right now. Let's see what we're working with, okay? So keep this in mind here. Make sure you have this written down in your notes somewhere. Okay, and when we look at an example here, you'll see exactly why it's important. We need to keep note of this, okay? All right. Put this over here for right now. Get that there. Let's go to the textbook. Okay, there we go. All right. So we're going to do here number 37. So let's take a look at number 37 here in the textbook here. All right, so example is number 37. All right, let's read this off here. Let's do this. All right. Toilet flushing. All right. In the healthy hand washing survey conducted by the Bradley Corporation, it was found that 64% of adult Americans operate the flusher of toilets in public restrooms with their foot. Suppose that a random sample of n is equal to 20 adult Americans is obtained and the number x who flush public toilets with their foot is recorded. Okay, so I don't know if you. I had a majority of people actually in my last class say that they flush with their foot. So I don't know who else does, but I think you know what? I never did this in the first class. I could do this now. We'll put a poll here. You guys can actually answer this. You guys flush with your foot. All right. Some people do, some people do not. So do you flush with your foot? Yes or no? I will have to mark no for myself. Instead, I wash my hands in the sink immediately after using a public restroom. So, but everybody is different in that scenario. So I'll be fully and forthright honest with you. So if you guys flush with your foot here. Wow, well, pretty even split here. I wash my hands too, JD. But some people do flush with their foot because they're like, it's kind of gross. I don't want to touch that, which is perfectly a valid response. Okay, I'm not saying that you're saying what you're doing is wrong. Okay, so I think that's a perfectly valid response to to a question like that. So let's see here. Yeah, so pretty much right down the middle here. So yeah, I mean to be fair, I mean although this particular scenario talks about 64%, but yeah, it's a pretty even split here. And again, the reasoning behind behind that here is either, you grew up washing your hands because that's what your parents told you to do or whatever. Or again, maybe you're like, it's kind of gross. My OCD is going to kick off. I need to flush it with my foot so I feel better. So that's cool too. Totally understand that. Either way, no problem. All right. Now, having said that, we're going to need to figure out some scenarios here. Now, letter A says, explain why this is a binomial experiment. Well, as you saw there was a 50-50 shot, right? I put up a poll there, and the poll said, do you flush with your foot, yes or no? Yes would be a success. You do flush with your foot. Or no would be a failure. You don't flush with your foot, okay? According to this scenario here, the success is yes, you flush with your foot. A failure is no, you do not. All right, but there's still one of two choices at the end of the day. Now, what we're going to look at here specifically is we're going to look at specific scenarios underneath number 37 here. So let's go over each of these particular problems here, and we will see exactly how to do this. All right. Let's do the first part here. This is part B in the problem. So part B says, find and interpret the probability that exactly 12 flush public toilets with their foot. So exactly 12. Okay. So let's at least get this going here. Let's put up another poll here. All right. So let's put up a poll here. Exactly 12. Would you use a PDF or would you use CDF here for this problem? Would you use binomial PDF or would you use binomial CDF for exactly 12? Go ahead and put it up in the poll. I put up a poll here. Would you use binomial PDF or binomial CDF? All right. Very good. Everybody got that right? Everybody said binomial PDF. Now, I totally agree with all of you here, even before the thing expires. All right. So remember, binomial PDF here deals with exactly the number of successes. Now, the question is, based on what you see here to the left, all right, what numbers are we going to put in underneath binomial PDF? Okay, what numbers are we going to put in specifically for binomial PDF? Let's first look at the first number here, which is the number of trials. What is the number of trials according to this problem here? What is the number of trials according to this problem here? So put 20. Okay. So according to the problem here, we have 20 people, right? We asked 20 people this question. So I agree with 20 as our first number here. That's absolutely correct. Okay. How about the next number here? What is the probability of success? What's that going to be here in this instance? What is the probability of success here? Let's go ahead and put up a poll here. Probability of success. What do you think we would put there? Put a probability of success. Go ahead and vote there. What would be your probability of success? think some people, like everybody's putting 0.64 here. Okay. And I can confirm here that it is indeed going to be 0.64. So let's take a look here. It was found that 64%, okay, it says it was found that 64% of adult Americans operate with their foot. So a success here is going to be 0.64. Okay, so 0.64 is correct. And according to letter B here, what is the, all right, so I don't need to put up a poll for this one here, but according to letter B here, what is the number of successes? What are we going to put for the last number there? What are we going to put up for that last number there? Go ahead and type that out in the chat. What's that last number I should put there for this one? 12. That's correct, right? Because we have exactly 12 people who flush. All right, so fine. I'm going to put 12. There we go. Okay, so let's take a good look here. This is what we're going to enter into our calculator. Jose. Truth. Truth, Jose. So let's go to, I'm going to quit out of here. Let's go to second in vars. Okay, so let's get to second in vars. We're going to go up to binomial PDF here. We're going to enter in our trials here, 20.64 and 12. Now, if you have an old school calculator, by the way, if you have an old school calculator, you could just write it exactly as you see here on the screen in the paint tool here. You can write it again 20, 0.64, 12. If you have the new school calculator, you don't have to do that there. The calculator will do that in your stead. So it should look just like this at the end of the day. And we go ahead and hit enter. And as we can see here, we get 0.1678. All right, so far so good. All right, before we move on here, are there any questions about what we just went over? Any questions? Nope. Okay. Want to be sure that everybody's on the same page here because we'll be going over several different types. All right. Well, let's move on here. Are we surrounded? Yes. Yes, we are, Planet. It was surrounded 4 decimal places, Planet. That's true. So that won't change. Okay, let's take a good look here at the next one. Okay, let's take a good look here at the next one. All right, so the next one here, I'm just going to read off the book here. So find and interpret the probability that at least 16 flush with their foot. So probability of at least 16. Okay. So let's answer this question here first. We're looking at least 16 here. All right, now what are we going to use here? Are we going to use PDF or are we going to use CDF? Are we going to use PDF or are we going to use CDF? Okay, so I agree with you guys. CDF is definitely correct, okay? 100%, all right? So I'm on board for that. Now, I want you to take a look here carefully. Take a look here carefully. What numbers should I use here for CDF? How am I going to solve for at least 16? Take a second to look at that carefully. Okay. What numbers are we going to use here for CDF in this instance for at least 16? What should I use here? Hmm. Okay, so Cheska says 20.64, so I'm going to agree with those two. So I agree with the first two parts there. However, Cheska, I'm not going to agree with the last number there of 16. What do you think it's going to be? The first two parts there, 20.64, 100%. I'm agreeing with you there. But what's that last part there? What should that last number be then? Hmm. Hmm. $17? Not quite 17 there. Not quite 17. Would it be 15? Okay. Okay. Now, I'm going to agree with you, Cheska, that it's 15 here. I'm going to agree with you with 15. Now, you're probably saying, because it's less than 16. Now, there's two parts to that question there. Now, you're probably saying, why is it 15? Now, first of all, let's take a step back here for just a moment, because I'm going to agree with all of you here and saying, hold up a second. Why is it 15? And number two, it's half of a trick question because we're actually missing one more part to this particular problem. Let's talk about that. Okay, so there's actually two parts that we're missing. We were missing the 15 here. That part is true. That's half of that answer. There's a second half to this answer here. And this is very, very important. This is where the wording here is going to play a very big factor. So let's be very careful about this. Now, let's draw a little picture here. When we say at least 16, we say at least 16. So that's going to be 16, 17, 18, 19, and 20. Okay? So that's what we want here. We want 16 to 20. All right? So what we have is we have all the scenarios here. We want 16 to 20 here. But in order for us to get 16 to 20, since this is what we want, in order for us to get that here, we have to get rid of all the scenarios here from 0 to 15. That's what we need to do here. Now you're probably saying, "Whoa, whoa, whoa, why are we forced to do that? Why can't we just go one way?" Well, because the reason is because of the limitation of what binomial CDF actually is. Binomial CDF, remember, means less than or equal to. It doesn't mean at least. It doesn't mean more than. It means less than or equal to. And it is a very restrictive in that regard. That is why I am going to say 15 would be part of my answer, but only half of it. The other half that we're missing here specifically is we're missing the rule of complements to go along with it. We need all the scenarios and then remove the first 15 of those scenarios. Okay? Mesit Ozil, there you go. Am I teaching stochastic processes as well? Not in this class, just well, a great question. Not in this class. I am teaching random variables, but not stochastic processes. I haven't done that in so long. Holy moly. Okay, so let's talk about this scenario here. We have a binomial CDF, again, out to 15, because we want to remove the first 15 scenarios, because we're working with less than or equal to. If I want at least 16, I got to take the entire scenarios, that's 100%, and I remove the first 15 scenarios here. So this is like 0 to 20, and then I remove everything from 0 to 15. So that's basically what this represents. This is like the cases from all the cases 0 to 20, all right? And this one removes all the cases between 0 to 15. Thus, that leaves you with specifically, that leaves you with equals, again, when you subtract that, it leaves you all the cases from 16 to 20. Okay, that's essentially what we're doing here at the end of the day in order to actually find out what the probability is going to be at that time. Underneath this scenario, that is. Okay. So let's go ahead and figure this out here. See what we get. So we go 1 minus secant and vars. Let's go to binomial CDF here. Okay. And let's put in our number here, 20.64, 15. And so here we get 0.1011, and there we go. We got it. All right. Are there any questions about that? Nay. Ooh, no P. Yeah. Moo indeed. The wars continue. All right. If there are no questions, I'm going to go ahead and put on another one of my own. This question here is my own question, but I'm going to use the same numbers here. Okay. So let's say we're doing the probability here. No, okay, perfect. All right, so let's have you guys take a minute here. I'm going to put a scenario here. Just take a short minute. Okay, so the probability of less than 14. Probability of less than 14. The probability of less than 14. Take a short minute here. Have you guys give that a try. Probability of less than 14. All right. Hey, Yusuf, how you doing, my friend? I hope you're doing well. Do we subtract 1 again? Not in this instance. Remember, what does it say? What does it say here, JD? Look at it carefully here, right? Wording means everything, right? JD, wording means everything here. It says, all right, less than 14. So let's go back to our notes here for just a moment. All right, don't forget, wording here is going to mean something very significant here, so be sure you're putting those numbers in the right places. But I will tell you, we're not subtracting 1 again because of the wording here of what the function does. All right, taking a little more than a minute here, that's fine. Can you guys tell me here, what would you put in, if we're not subtracting 1 here, to be fair, if we're not subtracting 1 here, what do we want to put here? How do we want to write this out? First of all, what function are we using here? Are we using PDF or CDF? Okay, 100% agree with all of you. CDF is absolutely spot on, okay? So we can at least establish that CDF is the way to be. Now, what numbers are we going to put in there for this scenario? What numbers are we going to put in there? I can certainly do that, Jose. .64 and 13. That is correct. Very good. Okay, so 20.64 and 13. Now, the reason why it's 13 here is because I said it's less than 14. So 14 is not included. All right, so if I said, let me put it as an aside here. So if I said 14 or less, 14 is included. Okay. But if it's less than 14, that means 14 is not included. So that is why we put 13 here instead. So note the difference in wording. 14 or less is not the same as less than 14. Okay, this is something that we talked about here back in chapter 5. All right, when we said, okay, we talked about wording in that instance as well. Well, guess what? That actually happened to be a pretty important thing. Okay, so again, want to be on the safe side here. Again, when we say less than 14 here, we don't want to include 14. Now we go ahead and enter this in here, and let's see what we get. We'll hit second in vars, binomial CDF. We'll hit 20.64 and 13. And so here we get 0.6197. Okay, good. Any questions about that? I hope there's any questions about that, guys. Ooh. All right. Okay, let's try another scenario then. All right, let's try another scenario. Yeah, let's go. Nope, okay. So let's go with the probability of more than 17. Let's go with the probability of more than 17. Probability of more than 17. Let's see how we can go ahead and do that here. Probability of more than 17. Probability more than 17. You guys tell me, how would you set this one up? How would you set this one up? More than 17. Right? Because the last one here is less than 14. Again, we've talked about the scenarios here of 0 to 13 is what we're looking for. More than 17. Same way as at least 17? You'd still use binomial CDF. Agree with that. Same way as at least 17? No. At least 17 does not reflect more than 17. Those are two different things. Is this PDF? No. PDF would mean exactly 17. So that's why we're not using PDF here in this case. I would say it'd be exactly 17, and then I would use PDF, but this doesn't say that. This says more than 17. Remember, at least 17 is not the same as more than 17. Two different things, just like we have up here. 14 or less is not the same as less than 14. Okay. Okay. 1 minus, okay. 1 minus what? All right. So I agree with you, Planet. Absolutely 100%. But 1 minus what? One minus the CDF. All right. 20.64 and 18. All right, so the first two numbers here are pretty clear. I think we're pretty clear on that part. That last number there, maybe not 18. What do we want here? What do we want, guys? If it says more than 17, what do we want, right? If it says more than 17, we want, let's write this down here. We want 18 to 20. Okay? That's what we want. We want 18 to 20 because that's more than 17. We want 18, 19, 20. That's what we're looking for there. Those three cases specifically. 18, 19, and 20. 16 would mean I would have 17, 18, 19, and 20 if I use 16 there, JD. Remember, if I say more than 17 here specifically, 17 is not included. So I'm going to take all the scenarios. Remember, 1 here reflects 0 to 20. I want to take away the scenarios here specifically. Yes, that is correct. I'm removing all the scenarios here from 0 to 17 to get 18 to 20. So I want 17 as my last number there, and that's correct. So I want 0 to 17, I just want to get rid of them. I don't want them in there, because then all I'll have left is the 18 to 20 scenarios. That's why I'm putting 17 there as the last number. Remember, the only reason why I do that is because binomial CDF talks about less than or equal to. Okay, less than or equal to. All right? All right. And I want to be sure that you guys can see that now. Yeah, so if you see that, Cheska, that's good, because this is kind of like the wording here. You can see it's very difficult when you first do it. It's very difficult. That's why we're going slow over these scenarios here, because it's not easy to see it right away about where all this stuff comes from, right? Why we're choosing to do it in this particular situation, why we're choosing to do it this particular way, is because we're very limited in what tools that we have available to us here in order to get this done. So if we go here to our calculator, let's go to the calculator here. 1 minus second in bars, binomial CDF, I have 0.64 and 17. All right. So if we look at that here specifically, in this particular instance, our final result here will be 0.0096. All right, seems fair. There we go. Okay. Any questions about that one here? We do have one more scenario to look at here, by the way. Not quite done just yet, but want to see if everybody is at least on board with what we have here right now. Okay. All right. Well, it is tricky. You have to read, like I said, the wording matters here. All right. Do you always use the same number given for more than when it comes to the last value? So let me expand. Let me see if I understand your question there correctly. When you say like more than 15, right? Would I use like this scenario here with like 1 minus and then with the 15 at the end? Is that what you mean? I want to be sure that's what you mean there. Okay. So the answer is yes. If you're using more than there, yes, that is correct. You would do 1 minus binomial CDF and then 15 would be your last number there. Because more than 15, for example, you would not include 15 as part of that scenario. However, do understand this thing here. All right, I want to make extra sure. Make sure you write this down here. All right, so more than is not the same as. So if I said, let me put it this way, more than 15, I'll just throw out a number here, just random number, is not the same as 15 or more. Okay. Two different things. So I want to make it extra clear to you. Write that down if you need to give yourself a reminder. But more than 15 is not the same as 15 or more. Much the same way as I said here, you know, so same thing here. If I wrote less than, same deal. So I want to remove those confusions for you, okay? So just make a note of that and be like, hey, I got to look at that carefully. When do you subtract 1? Okay. When do you do 1 minus, you mean? So the only time you do 1 minus is then when you have, say, a more than, okay, or an at least, or an or more, okay? So the reason why you take those specifically is because of the fact that in our cases here, because binomial CDF represents less than or equal to. So that's where you take the 1 minus part there when you have a more than, at least, or an or more. No, you never take 1 minus with the PDF. Unless you're looking at all of the scenarios around that PDF example. But we're not going to really run into that. It's never -1. It's always 1 minus, JD. So we're not going to use 1 minus with the PDF, by the way. If that's the answer to your question there. So I just want to be sure that all the scenarios are taken care of. We have one more scenario to do, by the way. Okay. We do have one more scenario to do. So let's go ahead and at least acknowledge that. It's kind of an extension off of your question there, JD. So let's look at the last possible scenario that you can see in these type of questions here. We're going to use the same numbers here as before. Okay, nothing's going to change in that regard. But let's look at this last scenario here. So F to pay respects. All right, so the probability here of, now I'm going to switch this around here. So I'll say here, so between 8 and 12. So I'm going to just switch the number. All right. So between the probability of between 8 and 12. All right. Now let me give you a hint for this one here. To be fair, let me give you a hint. All right. The hint is that you're going to use two binomials CDFs. Okay. You're going to use two binomial CDFs in order to solve this particular problem. All right. So let's give you guys a minute or so to go ahead and give it a try. And once you guys got a possible answer that we could try, then go ahead and post that in the chat. All right. So between 8 and 12. All right. And the hint is you use two binomial CDFs to solve for this answer. Here's a little tough. Let's see how it goes. All right. Anybody got a possible answer for me or possible way we can work this out? Go ahead and give that a go. Any possible way we can work out between 8 and 12? What do you guys think? I'll at least start off with at least on the first part here. I'm going to use binomial CDF here. What do you think we could use here, guys? What do you think? Go ahead and type out your guesses in the chat. That's fine. Okay, so, planet's got 20.64 and 12. Okay. Alrighty. I'm going to agree with you, planet. That is the first half of how you solve this particular problem. I completely agree with you. All right, so that's an excellent start. And we're going to need to do a couple of other things here as part of this problem. So what comes after that, planet, or anyone else? Don't forget we have two binomial CDFs, by the way. That was my hint to you. We have two binomial CDFs. Ooh, that's excuse me. That's pretty close. You know what, planet? I'm actually going to take the second half of your answer there. So ignore the one part there, but I will take the rest of that answer there. No problem. Let's talk about that here. So you actually have both parts here correct, but I'm just going to take it like this. Okay, so let me ignore the 1 minus part here. Now, the reason why is because of this particular scenario where we get between two values. Now, we are including between 8 and 12. So what we want here is we want all the scenarios here between 8 and 12. That's what we want here. Now, in order for us to get 8 to 12, 8, 9, 10, 11, and 12, we need to look at all the scenarios first from 0 to 12. That's what this first part here will represent, all the scenarios here from 0 to 12. Then, this second scenario here, we want to eliminate the first 7 scenarios. So I want to just be sure that I'll have 0 to 7 and 8 to 12. And I want to get rid of all the things that are between 0 and 7. That way, we get all the scenarios from 8 to 12 Those are the only scenarios that are left over at the end of the day. So that's where we get binomial CDF 20, 0.64, 12 minus binomial CDF 20, 0.64, 7. And then if we go ahead and subtract those from each other here, we're going to get our final result. Let's do it. Put second in vars. 20.4 and 12. Then we'll subtract. We have 20.64 and 7. And so here we get 0.4282. Okay. And that's going to be our final answer for this problem. Okay, any questions about that? Oh, no, you don't have to do that. You could just do it directly, just like I've done up here, Planet. No problem. All right. And that's how we can do that last example. Any questions, guys? Nope. All right. Well, I want to thank all of you here for coming on here to the stream once again. All right, that is where we're going to leave off here for today. We're going to do the last question here of 6.2 on Wednesday. That is what we are going to be heading off here to do. No, those are all the scenarios there, JD, that we are going to be covering here for this particular section. Okay, so that's why I've put every single scenario here in this one question. Those are the most. Those are the ones that we're going to be looking at. Okay, so I wanted to cover all the scenarios here in that case. 12 covers the scenarios from 0 to 12 here. Okay. Yes, but again, I told you wording was important, Planet. That's why we spent a whole class on it. This proves to be very useful for other scenarios that we'll see later on. So trust me. Even though this is talking about binomial distribution, this is definitely going to be useful in the next chapter when we talk about the normal distribution. So it won't be the last time we'll see this, okay? This I can guarantee you. Now, why do we use 12 but not 8? We use 12 here because we collect all the scenarios from cases from 0 to 12. Then we take away all the cases from 0 to 7 to remain 8 to 12. Remember, all we want to look here is that, remember, binomial CDF, well, what happened here? Binomial CDF is less than or equal to that number of successes. Okay, so I'm using that to my advantage here in this instance. So this is from 12 or less, and this represents 7 or less, so we get 8 to 12 that are left over here. That's why we go ahead and use 12 in that scenario there. Yeah, today is a little bit of a technical lesson kind of day because of what we're going to be seeing later. So I wanted to stress that wording here was very important here. So, okay. Any other questions? Moo. No. Alrighty. If there are no more questions here, I do have office hours here at 2 o'clock. So if you want me to step in, you can contact me here via Discord. My Discord is open. So if you want to contact me here via Discord, you can just put something in general chat if you want me to help. I can get back online here. I can restream if you would like. In the meantime, though, if not, then email me if you like, whatever you want. In the meantime, though, I want to thank you all coming out here for the stream once again. You guys are all wonderful. All right, thank you so very much. All right, if I don't see you for office hours, then I hope to see you on Wednesday. Okay, I hope to see you on Wednesday. We'll finish up here with section 6.2. The second question here, it's very quick, and then we'll get right into chapter 7, and we'll get going with that. All right, have yourself a wonderful day, everybody. All right, I hope you have a outstanding day. You guys take it easy. All right, and we will see you. We will see you later. All right, have a great one, everybody. Take it easy. Bye.